So far we have seen various techniques using which we can check if a particular number is a valid perfect square or not, right? Now let's quickly write the binary search based algorithm that we have discussed inside this our Python implementation. So here I have created a new file called isValidPerfectSquare.py. Inside that file I have basically set up the function that we will be implementing. So here if you want to be more specific using binary search also you can add it in the function name. Now here as part of the base checks, let's write the logic. Now if at all if this number that we have been given by the user, right, if at all if this number is less than 0, obviously valid squared values are never 0, right? So in that case we will simply return false here. Okay, if that is not the case, for example, if at all the number that user has given is equal to 1, or if at all the number that is given by the user is equal to 0, obviously 1 square is 1 and 0 square is 0 itself, right? So in that case we will simply return true. Okay, so these two are the normal cases that I would like to handle separately so that I feel it will give much more readability. Now let's write the logic for checking any other number if it is a valid squared value or not. So here, since we are going to use binary search based implementation, let me just define the range for the possible values. So here I'm going to define the start and I'm going to initialize it with 1, and end, obviously the maximum value it can go is basically num itself if it is a squared value. So end I'm going to initialize it with num itself. Like any other binary searching that we are doing, we are initializing the middle, right? I'm going to initialize it with middle with -1 as well. Now all we do is we will simply run a loop as long as the start is less than or equal to end. We will calculate the middle. So middle, since we are using Python 3, let me just import the math. Okay, here let's just do math.floor of start plus end divided by 2. Okay, once we get the middle, now all we do is we will multiply this middle by itself and we will compare it with the number that user has given. If at all this squared middle is equal to the number, in that case obviously the number is a valid square, right? In that case we will simply return true here itself. Okay, now if this is not the case, the other scenario is the middle multiplied by middle could be greater than this number and middle multiplied by middle could be less than the number. Now based on that comparison we need to restrict our search to only particular range. So for that, if at all this middle multiplied by middle is greater than the number that we have been given, that means the number is smaller than middle multiplied by middle, so it will be somewhere on the left part. So for that I'm going to update end with middle -1. If this is not the case, obviously the value could be on the right part. So for that I will update start with start plus 1. Okay, so that's it for this one. Now once we exhaust all the search ranges, basically we will come out of this loop, right? That basically represents that there is no value that is getting multiplied by itself to yield the number that user has given. So in that case obviously the number is not a valid square. That's why we will simply return false once we come out of this loop. If at all if we had found any other value which was yielding the number result, if it is multiplied by itself, then we would have written true here itself. But that is not what happened. We have not written true here. We basically have exhausted all the search ranges. We have come out of the loop. That basically means that it is not a perfect square, so we will return false. Okay, so that is what binary search way of implementing to check a particular value is a perfect square or not. So now let's just try to call this function and validate. Let's just define number. I'm going to initialize it with 16 and VP is equal to valid perfect square, and from here let's just try to print the return value from vp dot valid perfect square, and let's just pass the num itself. Okay, so if you see here, I'm passing 16, right? 16 is a valid square because 4 square basically yields 16. So if I run this right now, it should return true. That is what we have got. Similarly, let's just say I want to pass 17. 17 is not a valid square value, right? So if I run this right now, false is what we have got. Similarly, let's just say I want to test 100. 100 is like 10 square is 100. So I should get true. Okay. And let's just say I want to test for 0. 0 square is 0 itself, right? So true is what we have got. Similarly, let's just say I want to test for minus 10. Negative values will never be a perfect squares. So if I run this right now, false is what we have got. So whatever the solution that we have written is working, for all the different scenarios. If at all, if you want to check out couple of other scenarios, I don't think I have missed any other scenario, but you can still check out codingpal.org for this problem using the link in the description to see if I have missed any test cases. If at all, you can try evaluating your program against those test cases as well. Okay, and you can check out other solutions as well, even from the same link as well. Okay, so that's it for this one. I'll see you in the next problem.